Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 471, which is longest balanced substring 2. So the previous problem, the second problem was also same, but the number of distinct characters are different there. Okay. So what is the problem? The problem is we are given a string S, and only A, B, and C are present in the string. So that is very important case here, that only A, B, and C are present in the string. Now a substring S is called balance if all distinct characters in the substring appear the same number of times. Okay, so we have to find the length of the longest balance substring of S. So let's take one example. Let's take this one only. A, B, B, A, C. Okay. So let me write it here. A, B, B, A, C. Okay, let me increase the size. Uh, okay, one second. So So this is A B B A C. Okay. So now let me take another thing. I have recording for a long time, so okay, okay. My bad, my bad. Please wait for a minute. So this is A B B A C. Let's increase the font size a bit. Let's do it 36. 36. I think making it 36 will be good. So 28. So ABBAC. Okay. Now, what we have to find? We have to find the longest substring which has equal number of distinct characters. So we can take this one ABBA. Okay, ABBA. So here the number of A's are equals to the number of B's. Here one thing you have to observe is that we don't need to have all the three characters present in the substring. We can have two, we can have one, and we can have three. So now let's look at the constant for more observations. So here length of the string in S is 10 to the power 5. So n is 10 to the power 5. Now what is the optimal time complexity for this problem? The previous problem, the previous support, we have solved it in order of n square. So I am not going to explain that idea. Order of n square is quite trivial. So what we will do, we will just check if for every L to R, so we'll check S of R to A equals to S of R A minus S of R B equals to not sorry. So S of R A minus S of L A equals to S of R B and S of L B or not. So this is the standard algorithm we can follow for order of n square. So I am not going to go deeper into this order of n square algorithm, but we can take the help of this S of RA minus S of LA equals to S of RB minus S of LB. We can take help of this and try to solve this problem in lesser time complexity. Now let's try to think about different cases. Okay, so let's try to think about different cases. So we can try to solve this problem in three separate cases. First one is only one distinct character is present, so only one. Second case is only two distinct characters are present, and three is only three distinct characters are present. So these three problems does not have relation between each other, and we can solve these three problems separately. Now for solving the first problem, only one distinct character is present. This is quite trivial algorithm. So you have to take longest consecutive characters. Okay, so you have to take longest consecutive characters. So let's say we have something like A B B A A A, and then let's say C C C C like that. Okay, C C C C, and let's say again A B. So what we have to do, we can take two pointers. One is I and another one is J. Okay, so initially I and J will point to this. Now we'll continue incrementing J. Okay, we'll continue incrementing J till S of I equals to S of J. So now J will be incremented to here. Now we'll take the difference between them, J minus I. J minus I will be consecutive number of consecutive characters starting from I. Now we'll point I to J. Now again we'll increment the value of J by 1, J by 2. Now again the number of consecutive characters are 2 here. So like that, this is quite straightforward algorithm. So like that we can solve the problem on only one in order of n. Only one in order of n. Now here comes only two. Okay, now here comes only two. Now for only two, I'm not sure if someone else have solved this problem differently, but how I have solved this problem is only two is that I have taken different combinations. So I have taken the combination of A of B and another combination A of A and C and another combination B of C. I have solved the problem separately for A, B, A, C and B, C. So let's discuss the problem for how we have solved this problem for only AB. Okay. So let's take this on example only. We have something like ABB, let's say C, and then EBB, ABB. Okay. Now let's take it. Let's go through this example. So what we are going to solve is that I hope you have solved this problem when C is not present. If you have not solved this problem, but I will discuss the idea. Okay. So here we are considering A and B. Okay, A and B. So I will take A as plus one and B as minus one. Okay, I will take A as plus one and B as minus one. So this will be converted to one minus one minus one. Let's don't consider C. Let's consider C as anything. Let's say question mark one. Okay, this is one minus one and one. Now we have to find the longest array whose sum is zero. So we have to find the longest array whose sum is zero. The problem is changed to this. Now this problem is quite well known, but we have to do one trick here. Okay, whenever we are encountering C, we have to reset everything. So let's go through. Let's remember how we have solved the problem where we have to find the longest array whose sum is zero. Okay, so what we can do, we can take prefix sums. Okay, so let's consider this. The initial prefix sum is zero. So we store that in when 0 appears for the first time. So 0 appears for the first time at index 0. So let's say we are taking 0 as index. So 0 appears for the first time at index 0. Okay. Now our prefix sum is 0. When we are encountering A, our prefix sum will be 1. So 1 will be, so let's say encountering. So D of 0 is 0. The first time we encountered 0. Now D of 1 will be 1. Now again it becomes 0, 1 minus 1 0. Now we don't change the value of d of 0. We don't change the value of d of 0 because it is already set. So we again go to b. So this will be minus 1. So we'll say d of minus 1 as 2. 1 to 3. Okay. Now whenever we are at c, we have to erase all the values of previous d. So we'll erase all the values of d. Now now d will be empty. Now whenever we are resetting d, now you all observe that we have set d0 as 0. Again, whenever we are resetting, we have to set d of 0 as the index of c. So index of c is 4, so d of 0 is 4. So again we will continue the process, and whenever we are at some prefix sum c, we will check our answer will be I minus d of c. Okay. I will explain this part in the code. You will understand it better, or you can take some examples and try run it to solve the problem. Now we have solved the problem for only one and only two. Okay, only two is also order of n, and we are taking three combinations, so order of n into three. So order of n we have solved only one. Order of n into three we have solved only two. Now only problem left is our only three. Okay. Now only three. How are we solving the problem for only three? Okay. Now, one second. Okay, so previously I have written one expression. Okay, previously I have written one expression. So S of R A minus S of L A, S of R A minus S of L A equals to S of R B minus S of L B. Right? I have written this. Now let's take this R B towards this side. Okay, so we can say that S of R A minus S of R B, RA minus RB equals to S of LA, S of LA minus S of LB. We can write this. So we can see that this is a combination. S of RA minus S of RB is a like we are comparing these values. S of RA minus S of RB. Similar thing we can write for A and C. So S of RA minus S of RC, we can write this equals to S of LA minus S of SC. We can write this. Okay, S of LA minus S of LC. So what we can do, we can take a combination of these two values. Let's call this d of EB, and let's call this d of AC. So we can do the same thing. We can take the tuple of d of EB and d of AC and try to do the same thing we have done for only two. We can do the same thing for only two, and we will get our desired answer. So I will jump into the code and I will explain the code. I think you will understand it better. Okay, so let's jump into the code. So here I have solved it for only one. I am not going to explain this. This is quite trivial. Now let's jump into only two. Okay, only two. What I am doing, I am setting d of 0 as 1. D of 0 as 1. we are using one based indexing. Now, whenever si equals to a, we are doing sum plus plus, and if si equals to b, we are doing sum minus minus, and whenever si equals to c, we are doing d dot clear, and we are setting d0 as I plus 2. Why we are doing this? Because we are using our one based indexing. Okay, and we are trying to point this to the next integer. Okay, now if d of sum, if d of sum means that, and again another thing, we are using zero based index, one based indexing, and we don't want to use, don't want to set something as zero. That's why we have set d of zero as one, and that's why we are checking if d of sum, we are doing answer equals to maximum of I plus 2 minus d of sum. Okay, that's I got, I think you got it, why we are setting d of 0 as I plus 2 instead of I plus 1, because we can't set something as 0. Okay, so if d of sum, answer equals to maximum answer comma I plus 2 minus d of sum. Okay, this is for only 2, so I will call only 2 for ABC, ACB, and BCA. Okay, now this longest balance part is for all the three characters, when all the three characters are present. Okay, so we are setting d of 0 0 as 1. So what the two variables in the tuple, in the pair, represent? So the first tuple represent d of AB, and the second value represent d of AC. Okay, now um, so we are doing f of si minus a plus plus. This is the frequency. Now AB is f0 minus f1. So I go, f0 minus f1 will give us the count between s of 1 second. Uh, yeah. So f0 minus f1 will give us the difference between, f0 means the count of a, and f1 means count of b. So this will be give us this one. S of RD minus S of RB, and AC will give us A and C. Okay, now we are checking that D of A, B, and AC are present. If it is present, so we are setting answer equals to maximum of answer comma I plus 2 minus D of A, B, AC tuple. Okay, and if we are doing the same thing here, if this is 0, then we are setting D of A, B, AC as I plus 2. Again, we are doing I plus 2 here only because we are using one based indexing and we can't set something as 0. Now, our answer is set for all the three characters, when all the three characters are present. So we'll call answer equals to maximum answer comma only to ABC, ACBA, and ACB, and at the end we are returning maximum of answer comma only one of S. I hope you got the solution. The overall time complexity is order of n, and we are using maps, so it can also introduce a time complexity of log n here. That does not matter because n is 10 to the power 5 here. Uh, I hope you got the solution. I will attach the link of the code in the description box. You can check that out. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find the video helpful, please like, share, and subscribe.